Hello, I'm going to analyze this about a scientific paper. The title is Migrating from Legacy to Software-Defined Networks. Actually, it scientific paper analyzed from a network reliability perspective, and they are the author, Isa Medawar, Anwar Haque, and Hanan Lutfia. This article is focused on service reliability and its related aspects such as nodal reachability, network connectivity, and edge disjoint routing in both traditional networks and software-defined networks. It's called SDNs. Mainly, they are focused on reliability metric and calculate the statistical significance of the main differences of their reliability value between traditional network and software-defined networks. And their approach is not only shed light on enhancing reliability using edge disjoint path and a link failure scenario, but also they are focusing on to benefit the operators to achieve their service level objectives while migrating from legacy to SDN based platform. In this paper, they have a 6 session. The first session, introduction. In this introduction, the authors mention about 3 faults. The first one is a network element fault. Number 2 is a transmission fault, and number 3 is routing fault. And then session 2 is about related work, and session 3 is about network modeling. Session 4 is the reliability metric and its related aspects. And session 5 is mentioned network topologies and performance evaluation, which includes emulation, simulation, experimental settings, results, and discussion. And finally, the last session is a conclusion about this article. So we can see that in session 2, the session 1 is about introduction. They explain about what is a legacy network and what is the weaknesses and strengths in legacy network, and what is software-defined network. In this case, they mention what is the software-defined network. What is the software-defined networking? It's a deconverted control and data plane, which is different to the legacy network. In legacy network, control and data plane are coupled. And then they have a SDN controller, central point that can collect information and determine the best forwarding policies. So it is about the introduction, and then I'm going to show you about in this case they are going to calculate 3 reliability. The first one is 2 terminal reliability and K terminal reliability, and the third one is all terminal reliability. As related what? Session 2. In this case, and then they also mention in an introduction about why most of the companies don't want to take a risk from migrating from legacy to the SDN network. The main reason is the large budget required to migrate, and then the second one is the migration to SDN based network is not a priority investment for network operator because they don't have a special research for the STM base, especially in reliability for the STM based network and legacy network. And in section 2 a related word, they mention about controller and mesh beside. I'm sure. And then the section 3 is the network modeling. In network modeling, they mention a lot of formulas how to calculate when a link is failed in your network. In this topology, you can see that the straight line is the pre-fail and the dotted is the post-fail. So, and in this situation, when the link is failed, how STM based network will recover the failure link from source to destination. And they also mention about the reliability metric by using a formula, and they calculate 3 reliability that I mentioned before. The first one is 2-pair reliability, k-pair reliability, and all-pair reliability. And this second example of the topology, and then this is a formula of the how to calculate traffic route and how to recover the link failure and when a link is failed in your network. So if you want to read, you can read detailed information, and then this is a result or iteration and introduction. They mention they will make a link fail randomly, and then when the link is failed, they are not going to restore this failed link. So for example, for the iteration for in this network, in this topology, when the iteration they will make a link fail, maybe after 5 times it stay better, but when the iteration is sick, so there is traffic from source to destination because the link is failed near the node. You can see that in iteration 6 all the number are turning to the 0. And then they are mentioning about the reliability characterization, how to calculate and how to measure reliability. And they also mention about the reachability, because reachability and reliability is related to each other. So without the reachability, we can't measure reliability. We can calculate performance of the reliability. So this one they also mention about the reachability, but the main reason of this paper focus on reliability of STM based network and legacy network. You can see that a lot of mathematical instructions. And then this is a table. In table, you can see that this is EPND is an expected package not delivered, and then PPOPR is the present probability of packet loss, and then the last one is a network package in direction and duration ratio. This is a mathematical calculation, and then you can see that in this article they use three network types to calculate reliability between inboard software defined STM based network and legacy network. The first one is a tree topology, and the second one is mesh topology. You can see this is a tree, this is a mesh topology, and the last one is the hybrid topology. And then this one is a controller, and they use for the connection between switch and controller, they are using open floor. I will mention later. And then you can see emulation and simulation environment. In this case, they use a mini NAC version 2.2.2 and with open vSIG, open vSwitch. OVS, the version is 2.5.4, supported by OpenFlow version. And also they are using they are running on Think Central Desktop, Intel Core i5 6th generation and 8GB RAM. And then the operating system is 64-bit Ubuntu. The version is 60.04 LDS. And then they tested these network types on a 4 level, original, 2 level, and 3 level, and 4 level. The original is link, S equal to the switch, and H is host. So for the link, and for the 2 level they double, and the 3 level they treble, and they folder. And then switch, they just add 2 to the another level. And then for the host, they just plus 4 to the next level. Maybe the original one is 4, the 2 level is 8, maybe the 3 level is 12, and the 4 level is 16, etc. And then after testing performance analysis, this article showed the graph between STM based network and legacy network. In the first graph is showing reliability over STM based and legacy based. You can see that when the link is failed, the first recovery analyzes on reliability based on STM base is faster than legacy base, but the time is running, they are almost the same, the result. But initial state, I think initial state reliability over STM based network is faster than legacy network. And this is a 3 result, and this is the mesh result, and then this is a hybrid result. In hybrid result, the results are the same. They are mentioning about the information, their results. And then this is a table, and you can see that there are a few numbers that is different between STM base and legacy base. They highlight the number. You can see that is a little bit, but other numbers are almost the same. And then they also prove the flowchart or calculation reliability through simulation. And then there is a topology about EPNT, PPOPR, and MPNTR. And in this case, some cases, for example, tree and mesh topologies results based on STM based network a little bit faster than legacy network, but hybrid network legacy network is a little bit faster than STM based network. But final reason for the conclusion, this is the hazard rate, and for the conclusion they mentioned that STM based network had comparable result with the legacy based network. And there is the main reason STM does not improve the operational reliability is that because OpenFlow driven approach suffer from the coverage problem, because of the control plane always would take too much response time to detect the failure, and then they have to it had to send the updates to be installed in the important OVS switch. So it takes time. So in a real network, they are not waiting the response time. The at least response time is 4 seconds as a default. So for the conclusion, in my case, this article, from my point of view, this article provide an insight into network reliability and link failure scenario, and all the results are the same, and it means SDM based network are comparable with the legacy network. And then the result of their experience suggests that fast failure detection and recovery was crucial to enhance operational reliability in SDM-based network. From my point of view, this article is a strong scientific paper, and then they have a strong scientific study, because it had been published in 2021 decimal. But they focus on reliability because there are a lot of specialized research focus on reachability. So that is why they mentioned that they want to focus on reliability, because reliability is also very important in the network, in the industry, for communication. But I think this is a great research for the future to do the further information about the SDM base and legacy network, how to compare. Thank you. These are references, and thank you very much for your attention.